I'm Anil Kumar. Welcome to my series on trigonometric identities. And let me thank all the viewers and subscribers for their request on this topic. I'll take up 5 examples, all multiple choice. And all these examples have one thing in common, and that is we are going to use Pythagorean trigonometric identities to prove. So this is application of Pythagorean trig identities. So basically we have 3 of them. One is sine square theta plus cos square theta equals to 1. And if I divide by sine, then we get 1 plus cot square theta equals to 1 over sine, which is cosecant square theta. And if I divide by cosine, then we get tan square theta plus 1 equals to secant square theta. Correct? We'll see how these formulas can be interchanged and then solve some questions. Also remember that when we say what is tan theta, we'll use tan theta as a ratio of sine theta over cos theta. Correct? This is all what you need to know to solve these 5 questions. So first let's have a look at these questions. The first one here is tan x minus cot x divided by tan x plus cot x is what? Question number 2, 1 minus 2 sin x cos x divided by sin x minus cos x is equal to what? Then question number 3 will be 4 plus tan x minus cot x whole square is equal to, 4 options are given to you. You can actually pause the video, copy these questions, solve, and then look into my suggestions. Question number 4 is square root of 1 minus cos x divided by square root of 1 plus cos x is equal to what? Now these are very popular questions from test point of view, so they should definitely help you in getting better marks. The last question here is slightly different, which is if tan x plus secant x equals to x, then which one of the following is true, right? So then which one is true? Then let me see, then what is tan x? Okay, so these are the 5 questions for you. You can pause the video, answer these questions, and then look into my suggestions. Now I'll take up these solutions one by one and let us see how to solve all these questions. Okay, so let's begin with solving the very first question now. So what we have here is tan x minus cot x divided by tan x plus cot x. Whenever you're given equation in tan and cot, it is a good idea to just write them in sine and cosine. So let me write this equation as sin x over cos x minus cos x over sin x divided by sin x over cos x plus cos x over sin x. Now we can take common denominator and rewrite the given expression as common denominator is cos x sin x. And what we get here by cross multiplying is sin square x minus cos square x. In the denominator also, we'll take the common denominator, which is cos x sin x. And when you multiply, cross multiply, you get sin square x plus cos square x. So clearly from here you can see that their denominators will cancel, right? And what you get here is sin square x minus cos square x, right? Since sine square x plus cos square x is 1, so this over 1 you get, right? So this expression, is 1. Now the choices given to us are very different from what we got. We have this in sine square x. So let's rewrite cos square x as 1 minus sine square x, correct? So you could actually interchange, right? And you could write sine square x by taking cos on this side. So in that case, what I will do here is rewrite the right side as sine square x minus 1 minus sine square x. Now that gives you sine square x minus 1, and when you open the bracket, this becomes plus sine square x. And so you get your result 2 sine square x minus 1. So the option A is the correct option. Is that clear to you, right? So that is how you're going to solve. Perfect. Let's move on and take up question number 2. Question number 2 here is 1 minus 2 sin x cos x divided by sin x minus cos x is equal to what? So this expression, you can write 1 as sin square x plus cos square x, correct? So that's the Pythagorean identity, which you learn sin square x plus cos square x is equal to 1. So I replaced 1 with sin square x plus cos square x, and we have minus 2 sin x cos x divided by sin x minus cos x. Now the numerator could be written as sin x minus cos x whole square, right? So the numerator now could be written as sin x minus cos x whole square, and we have denominator here as sin x minus cos x, right? So this is, a minus b whole square is what? A minus b whole square is a square minus 2ab plus b square. So that is that 2ab term, right? So that is how we get it. And now from here you could cancel this 2, the square part, the second factor, with the denominator. And what you get here is sin x minus cos x. That is option A, right? So this is equal to sin x minus cos x. Is that clear? So that is how you would actually solve such a question, right? Now let's take up the next example. Now I think the concept is absolutely clear to you. I'd like you to pause the video, solve it yourself, and then look into my suggestions. Now here the expression given to us is 4 plus tan x minus cot x whole square is equal to what? Now we'll begin with what is a minus b whole square. So we'll expand the term in the bracket. So what we get here is 4 plus tan square x minus 2 tan x cos x cot x plus cot square x, correct? Now the term 2 tan x cot x is basically equal to 1, right? So let's write down this as 4 plus, let me do it in steps, tan square x minus 2 tan x cot x is 1 over tan x. So that will cancel, leaving us with 2, right? So we get here 4 plus tan square x minus 2 plus cot square x, right? So you get minus 2 because these tan x cancels. Now we have 4 minus 2 is 2. So we get 2 plus tan square x plus cot square x. We have options in secant and cosecants. So what we could do here is split this 2 as 1 plus tan square x and 1 plus cot square x. So once you do that, what are you left with? 1 plus tan square x is secant square x, correct? So that is the Pythagorean identity which you just learned. And 1 plus cot square is is cosecant square x. So that's what you get. So the option B is the right option for you. Correct? Let's move on and take up the next question, which is question number 4. Here we have square root of 1 minus cos x divided by 1 plus cos x. So in such questions, you should rationalize. So the idea is to rationalize. So to rationalize, we'll multiply and divide by the conjugate of the denominator. So this particular expression can be written as square root of 1 minus cos x over square root of 1 plus cos x times conjugate of 1 plus cos x is 1 minus cos x, correct? Over square root of the same term. So you're effectively multiplying by 1, so you don't really change the expression. So what you get here is, here when you multiply it becomes square, so you get 1 minus cos x in the numerator, and in the denominator we get 1 minus cos square x. That is 1 plus cos x times 1 minus cos x. Now what is 1 minus cos square x? 1 minus cos square x is sine square x. So we have 1 minus cos x over square root of sine square x. And that should give you 1 minus cos x over sine x. So this is equal to 1 over sine x minus cos x over sine x. Now the reciprocal of sine x is cosecant x. So you get cosecant x minus cotangent x, which is option B for us, correct? So that is how you're going to find the solution of this particular expression, right? So you get equivalent expression as shown here. The last one here is, if tan x plus secant x equals to x, then what is tan x? Now, we are given tan x plus secant x as equal to x. Let us also remember that there is an identity which is 1 plus tan square x is equal to secant square x. Correct? Now, if we rearrange, we get 1 equals to secant square x minus tan square x. Now this is difference of squares. I could always write this as secant x plus tan x times secant x minus tan x. Perfect. Now what are we given? We are actually given that tan x plus secant x is equal to x. So we are given tan x plus secant x equals to x. So we could replace this term with x. So we get 1 equals to x times secant x minus tan x. So from here we get the value of secant x minus tan x as 1 over x. So 1 over x is secant x minus tan x. So we get an expression for secant x minus tan x. So we know what is secant x minus tan x. That is equal to 1 over x. Now these two equations can help us to find the value of tan x. Correct? So if I do equation 1 minus equation 2, right? So if I do equation 1 minus equation 2, I get 2 tan x equal to x minus 1 over x. Correct? Now what is x minus 1 over x? It is x squared minus 1, taking x as a common denominator. So we get the expression for tan x. So tan x is really equal to x squared minus 1 over 2x. Is that clear? So this is our option A. So option A is correct option for this particular question. So I hope that helps. So that covers a variety of questions which are based on trigonometric Pythagorean identities, where we learned that tan x could be written as sine over cosine, and we know the basic trigonometric identities. Sine square x plus cos square x equals to 1, 1 plus tan square x equals to secant square x, and 1 plus cotangent square x is equal to cosecant square x. So I hope that helps. Feel free to write your comments and share your views. If you like and subscribe to my videos, that'd be great. Thanks for watching, and look forward to more multiple choice questions to review the concepts learned in trigonometry. Thank you and all the best.